Hello everyone, welcome to Electronically Connected. In this video, we will be continuing with our topic of encoder and focusing on a very important encoder which is called the Priority Encoder. If you haven't seen the other videos of our encoder, I request you to please go back and see the videos discussing what an encoder is and how it is constructed. So let's get started. So let us begin by focusing on what a priority encoder is and how it is different from the other encoders that we have studied in our previous videos. So an encoder is used to reduce the number of wires needed in a circuit. And how does it do that? It does by giving coded output by assigning a priority to the number of bits of input. I'll explain this. So a priority encoder can have more than one inputs activated at the same time. If you remember from the previous videos, the inputs were activated one at a time. Once for one particular combination, Y0 was active, and then for the other combination, Y1 was active, and so on. But for a priority encoder, it does not matter how many number of inputs are activated because one particular input is given a priority. So let us take an example. If we have an encoder with 4 inputs and 2 outputs. Again, outputs are A1 and A0. And my inputs are Y3, Y2, Y1 and Y0. So the priority is decreasing. Y0 has the highest priority when defining and Y3 has the lowest priority. So that means if I want to declare that Y3 is 1, whatever the combination is present at Y1, Y0, it does not matter. So we can declare it as don't care. Similarly, if Y1 is 1, then Y0's it can be 1 or 0, it does not matter. So if Y1 is 1, Y0 does not matter. It can be 1 or 0, it does not matter. The output will be the same. Let us see the truth table for this. So because we have 4 inputs, we're going to have 4 combinations. Now when all the inputs are 0, then the output is don't care. Now Y0 has the highest priority. So when Y0 is 1, it's 0, 0. Now when Y1 is 1, it does not matter if Y0 is 1 or 0. So we declare it as don't care. And the other combinations are going to be 0 as previously. So when Y1 is 1 and Y0 is 0 or 1, which does not matter, the output is 0, 1. Similarly, moving to the lower priority, Y2 is 1 and Y1 and Y0 is again don't care and the output is 1, 0. And for the lowest priority, Y3 is 1, then Y2 is don't care, Y1 is don't care, Y0 is don't care and the output is 1, 0. Just to remind what is don't care, that means it can be 1 or 0. So if we take this logic, so that means if the input is 0, 0, 1, 1, then the output is again 0, 1 only. Also, if it's 0, 0, 1, 0, then the output will again be 1, 0. So if Y0 is 1 or 0, it does not matter. So don't care, denoted by X, the output will be the same. Now let us form the equations for A1 and A0 using a K-map. Please refer to my previous videos if you are not familiar with how to use a K-map to form a Boolean expression. So let us start filling up our K-map. We see that the inputs are Y3, Y2, Y1 and Y0. So when 0, 0, 0, 0, then A1 is don't care. This is for A1 and this K-map is for A0. So we have don't care. Then we have 0, 0, 0. We have 1, 1, 1, 1, 1, 1, 1, 1 and again 1, 1, 1, 1. So let us try and form the groupings over here. So we have 2 groups. This is our first group and this is our second group. So in the first group, we can see that Y3 is common in both of them. This is for Y3 is 1 and the other things are changing. So we have Y3. And then moving on to the next group, we have this group where Y2 is common. So Y2. Now moving on to the equation for A0. So when y3, y2, y1 and y0 is 0, 0, 0, 0. That means 0, 0, 0, 0, which is x. So we have X. And then we fill up the other spaces similarly 0, 0, 0, 0. And then for these two combinations we have 1, 1, 1, 1, 1, 1, 1, 1. Now forming the groups again. So this is the first group that gets formed. And the second group is 1, 1 and these 1, 1 to maximize the number of ones in one group. So for this particular group, the equation is this one is common, that corresponds to y3. So we have y3 plus for this other group of 1, 1 and 1, 1, we have y2 bar and y1. And hence these are the two equations for A1 and A0 for a priority encoder. And these can be materialized into circuits using OR gates and 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 NOT gates. Hence a priority encoder is really important because with the help of a priority encoder, we can set the priority of a particular bit in my input combinations and not care about the other combinations preceding it. So with this, we come to the end of our video. Thank you for watching. Please like, share and subscribe to my channel. See you next time. Till then, happy learning.